Section 5.6 is sums and differences of rational expressions, and the objective here is just to add and subtract rational expressions. So the simple rule that we know is to combine fractions by an operation of addition, you have to have the same denominator, called a common denominator. And when that occurs, this rule holds true. So for example, 1/2 plus 2/2 equals 3/2. Common denominator carries over, the sum of the numerators carries over. Now what if we had something like this? 3/8 plus 7/12. Clearly we don't have a common denominator here, so we have to make a common denominator. And a lot of people think of just multiplying the denominators. But let's prove actually how we can find a common denominator the easiest and most efficient way. The way to do that is by listing the factors of the denominator. We're going to list all of the prime factors here. Now what we'll notice is that 3 times 2 times 2 is 12, 2 times 2 times 2 is 8. But when you want a common denominator, you want there to be all the same factors. This has 2 3 times. This only has 2 twice. So we can start by multiplying this fraction by 2/2, so that we now have 3 2's down here. But over here in this fraction, we're missing a 3 in the denominator. It's here. So let's multiply this one by 3/3. This gives us numerators of 9 and 14. And notice our denominators are now the same, because they have all the same factors. If denominators have the same factors, they have to be the same. 2 times 2 times 2 is 8. 8 times 3 is 24. So there's our common denominator of 24. 8 and 12 both go into 24. And now we can add them together, giving us 23/24. So the same method is going to be applied with variables by finding a common denominator by using factoring. The steps here, and first of all, if a problem is subtraction, just write it as adding the opposite. But the steps are, first factor the denominators completely, then find the least common denominator of each fraction. You can do this by multiplying the numerator and denominator of each term by what is missing in the denominator, and then leave the denominator in factored form. Then add or subtract the numerators and carry over that common denominator. And then finally, step 4, if the numerator can be factored, go ahead and do that and then possibly simplify. So let's take a look at an example now. Here in this one, we're going to start, first of all, it's addition, so we're good. Next, we'll start by factoring all the denominators completely. Some denominators are easier than others. The one on the right is obvious. 3x comes out, leaving behind x plus 1. On the left-hand side, though, it's not as obvious, but it's 3x times 3x. Next, we want to make a common denominator, so we say to ourselves, well, x plus 1 is over here, but it's missing on the other one. So let's put x plus 1 here. We'll put it here. Then over here on the right side, we'll notice that there's 3x, but there's 2 3x's on the left side. So we're missing a 3x over here. Okay, and remember to put all this stuff in parentheses. Now we'll take a look. The numerators we can multiply out, so distribute the 7. Becomes 7x plus 7. Over here, 3x times x is 3x squared. This plus sign carries down. And now that there's a common denominator, we're done with the denominators. We can just write it once. We don't have to do any more work. And there's the common denominator. I've copied this down from right here. Now, it doesn't matter whether I copy this or this, because multiplication is commutative, so the order doesn't matter. But we're going to leave the denominator in factored form. The reason we're doing that is so we can rewrite the numerator first. And what we'll notice here, there should be an arrow, what we'll notice here is that if the numerator was able to be factored, and if one of those factors were x plus 1, we could cancel it or reduce it with this x plus 1. But it turns out that it's not factorable, or not factorable into anything that would cancel. So we leave this as our final answer. Okay, this is left alone. You could obviously rewrite it with the denominator as 9x squared, x plus 1, in the numerator the same way also. But that is not necessary. Unless you're taking like an SAT exam and it's written in this form, you need to realize that this is the same thing as this. So example 2 says to determine the difference below. And right away it's a difference, so let's write it as adding. So let's think of this as x plus 2 over 2x minus 2. And then we're going to add the opposite. So we're going to add the negative quantity of this whole thing. Now be careful. When you add the opposite, it's really like you're adding the same thing, but you're multiplying it by a negative 1 here. And this is really over a positive 1. So you're only negating the numerator terms. So this becomes x plus 2 over the quantity 2x minus 2 plus, now negative 1 times negative 2x is 2x. This is going to be plus 1 all over x squared minus 4x plus 3. Now let's go ahead and factor this to come up with a common denominator. On the left-hand side, our factor GCF is a 2. So it's 2 times the quantity x minus 1. And on the right-hand side, we have 2x plus 1 as the numerator. And the denominator here factors into x minus 3 and x minus 1. So we then have to say to ourselves, well, okay, you know, what's missing? Looks like over here we're missing x minus 3. Now if I put it in the numerator like that and extend my fraction line, I need to remember to put parentheses here. Because x plus 2 is a quantity, and x minus 3 is a quantity. We have to multiply those whole quantities by each other. Now over here we're missing a 2. And that has to have a parenthesis around it. And now if we look at our denominators, x minus 3, 2, x minus 1. x minus 3, 2, x minus 1. We have a common denominator. In the numerators now let's distribute. X minus 3 times x plus 2 is going to give us x squared minus x minus 6. This is going to be plus. Distributing this, we're going to get 4x plus 2. All over the same denominator, so I'll just write it once, and I'll write it in this order. It doesn't really matter what order for the denominator. Now looking at your numerator, let's go ahead and simplify the numerator. It's going to be x squared, it's going to be a positive 3x, and it's going to be a minus 4. All over 2 parentheses x minus 1 parentheses x minus 3. Well, this numerator factors. It factors into x plus 4 and x minus 1. And clearly we're going to see here now that these cancel. So that was step 4 of our steps to see if anything reduces. And when that reduces, our final answer is x plus 4 over the quantity 2 times the quantity x minus 3. Now, this is your final answer, but if it's on an SAT, consider the fact that it can be written like this. Okay, where the bottom is distributed.